Alright, in this video we're looking again at a variety of functions and we're being asked to find the critical numbers of a function. And the critical numbers I'd like to find in this problem are of the function x times the square root of 1 minus x squared. And that's the graph that we're seeing here in blue. We're seeing the graph of the function. Okay. A couple things to note about this graph is that we're seeing that when we start looking at and trying to sketch the derivative, we can see right here that there is a place where the derivative is negative, right? So that's why we're seeing the derivative being negative here. But right in here, the derivative is still negative, right? Right here at this location, because it's sloping downward. But there's some spot here, it's kind of hard to see where it is, but we can see right from the derivative graph that there is a place where the derivative is equal to 0. So what we're interested in finding is this critical number of the function f of x. Okay, and it looks like, according to the graph of the derivative, that there is another critical point, another critical number. Okay, so let's go ahead and do the math behind finding these two critical numbers. And I'm not sure if you can see it, but it also looks like this function, right, that this derivative function is going to be trapped between some values. So it looks like we have some vertical asymptotes. So let's see what happens here with f prime of x. The derivative is going to require the product rule, so the first multiplied by the derivative of the second plus the second times the derivative of the first. Okay. Now the derivative of the square root is going to require the chain rule, so it's going to be 1 over 2 square root of 1 minus x squared. That's the derivative of the outer function. And then there is a derivative of the inner function of, let me see, negative 2x. Okay, plus, let's see, plus the square root of 1 minus x squared. Okay, so there is our derivative. Okay, and the 2's will end up canceling, so we will get negative x squared over the square root of 1 minus x squared plus the square root of 1 minus x squared. So there is our derivative that we somehow need to work with. Okay, so I'm going to come over here just so I can have a note for myself. X multiplied by the square root 1 minus x squared. I'm going to find the derivative of that function with the computer just to check it, and we're getting the same answer that we got. So let's move to the next page and start working on the solving of this equation. Okay, so we're going to have f prime of x is equal to negative x squared over the square root of 1 minus x squared, okay, plus the square root of 1 minus x squared. Okay. And we'd like to figure out when that is equal to 0 or when that does not exist. Okay, so I think one thing that we can see here is that this derivative f prime of x does not exist when x is equal to 1 and negative 1, because we're getting the division by 0. Okay, because f prime of x is divided by 0 at x is equal to 1 and x is equal to negative 1. So this is the first example where we've seen where we can get some critical numbers from the function's derivative not existing. Okay. Well, let's continue on. There might be a place, is there a place where the derivative is actually equal to 0? Are there other critical points? So we need to look at this equation, x squared over the square root of 1 minus x squared, and we need to set that equal to 0, so I'm going to move the square root to the other side with a minus sign. Okay. Now, I'm really not a fan of all these fractions and square roots, so I'm going to multiply both sides by the square root of 1 minus x squared to give negative x squared is equal to negative square root of 1 minus x squared multiplied by the square root of 1 minus x squared. So this one and this one canceled, and now I need to multiply this out on the other side to get negative 1 minus x squared. And now we'll see if this is actually going to be an equation that we can solve for x, and it looks like we're going to have a chance because 1 will be equal to 2x squared. So x squared will be equal to a half, which implies that x will be plus or minus the square root of 1/2. Okay, so there are all your critical numbers. X is equal to 1, x is equal to negative 1, x is equal to the square root of 1/2, x is equal to negative square root of 1/2. So there are all your critical values. And we can double check this on the computer. I could say solve f prime of x is equal to 0 for x. And there are the answers that we expected. I could turn those to decimals. And if we go back to the graph that we were seeing earlier, right, can we see that things are making a little bit of sense? We did actually have vertical asymptotes in the derivative at 1 and negative 1. And that's why we have critical numbers at 1 and negative 1, because the graph of the derivative has a vertical asymptote. And we can see here that this value, these two critical numbers, are less than negative 0.5, but not as small as negative 0.1. So that's negative 0.707, or the negative 1 over square root of 2. And this value right here is 1 over square root of 2. Alright, so ends this video on another example of critical points, and other videos will continue on with the local max-min problem for a function.